Good morning, geometry class. Hope everybody's doing well. Hope you had a great weekend, a safe weekend in spite of all that's going on with the rioting in Philadelphia. We've been praying for everyone, for God keep His hand of protection upon them, and so continue to stay safe. And we're getting near the end of this book. Good news, the end of school is this week, and so I'm excited to get near the end. Stay focused, work hard, continue to get your homework in these next couple days as well. We're going to pick up on page 25. Page 25, Glide Reflections. Okay, this is our fourth transformation. Our fourth transformation. So the kind of transformations that we've looked at so far are reflections. And remember, reflection is a simple mirror image. We learned to reflect an image over a line and then over a point. And then we looked at reflection, then a translation. A translation is a composite of two reflections over parallel lines. And then we looked at rotations and two different kinds of rotations there. And then tonight we're going to look at glide reflections. And so we'll get these four, our fourth transformation. Then we're going to take the checkup today. You need to take the checkup, so you can pause the video, take the checkup, and then we're going to do a few pages after the checkup, and we're going to look at symmetry. And so hopefully the goal is to get to page 34 today. So we're going to pray, and then let's get started. Lord, protect each and every student. It's been crazy in Philadelphia and around our country. God, we ask that you would intervene and have your will and your way. Give our authorities wisdom. Protect, again, every student. Give us wisdom as we begin this math class today. I pray anoint every heart and mind, each student to work hard and diligently. Will give me the ability to explain these principles as I ought. In Jesus' name we pray. Amen. A glide reflection. So figure 6 on page 25. Let's look at the glide reflection, which is the fourth transformation. The transformation, just like its name suggests, is composed of a glide, a translation. Remember, a translation moves from one point along another point, and a reflection. So we're going to have a glide reflection is a translation and simply a reflection. Now I want you to highlight a glide reflection here. You will see this on the self-test and again on the PACE test. Is a composite. So it's composed of two things, a translation and a reflection over a line that is perpendicular to the lines of translation. So we'll see that in a second. In figure 6, notice in figure 6 on the right hand side of your page, we have triangle ABC. All right, and then it's reflected across line L. So we see that there, reflected across line L, and then it is reflected across line M, and then simply, again, it is reflected over line N. You see, so we have two reflections, two translations, and then a reflection. Now, I want you to notice the very bottom sentence, the very last sentence of the paragraph. It really basically boils up, sums up the principle of a glide reflection. And so basically, a translation is a composite of two reflections, as we have seen. A glide reflection is the composite of three reflections, where two of the lines reflected are parallel and the other is perpendicular to the lines. And so we're going to see this today. We're going to do on page 26, we're going to do number 3 and number 6. I have them already on the board. And remember, don't want to forget that a glide reflection is an isometry. So remember, an isometry is a distance-preserving translation. And so we want to preserve the distance. Notice we have the arrow, which is pointing the direction of the translation. And then we want to measure this line segment. Now, again, mine is not to scale, so I believe I have a 4-inch line here, and I believe in your book you have, let me just simply measure this. Yours would be 1.25 inches. So you're going to move your line segment 1.25 inches to the right, and then 1.25 inches down past the line. So let's do these simply together, okay? Let me get my marker here. This is number 3. We're going to do number 3 together. So again, mine is going to be a little bit different than yours. So yours is going to be 1.25 inches. I believe mine's going to be, all right, 4 inches. So, all right, so starting from line N, all right, so what we're going to do is we're going to go across. So, all right, take your straight edge there, whatever you're doing. Okay. All right, we're going to call this N prime. All right, so just go to point P here. We'll call this P prime, and then O, point O. We have O prime. And now I'm just going to simply connect my line segment, so N to O, and then O to P. All right, so, okay. Now this is a translation, so it looks like it's gliding across the page, and now we're going to reflect it over line M. Reflect it over line M, so we want to make sure, again, that we have like our line segment here, so 1.25 inches, so I'm going to go through here. Okay. All right, we're going to call this O double prime. All right, so, all right. Okay. Call this N double prime, and then P double prime. Now, again, what you want to make sure that these auxiliary lines here are perpendicular to line M. Be sure they're perpendicular, and then I'm just going to simply connect my line segments here. So we have our glide reflection. There we go. So a translation and then a reflection. So maintaining the distance here. So yours is 1.25 inches. So you should move all your auxiliary lines 1.25 inches. So from N to N prime, P to P prime, O to O prime should be 1.25 inches. And then N prime to N double prime, P prime to P double prime, and O prime to O double prime should be 1.25 inches. So we're preserving, and isometry is distance preserving. Okay, let's do number 6. Okay, number 6 here. So what we have here, again, your line segment, let me quickly measure. Your line segment should be, again, 1.25 inches. My line segment here, again, is a little different here. So I'm going to go 5 inches here to each one. So again, we're going to glide this, translate this across the page, and then we're going to reflect it over line L. So from each line segment, take your distance here. Again, mine is going to be a little bit different. All right. Call this L prime. All right, from here. Okay. This will be O prime. All right, O prime, L prime. All right, then do the same thing from M. So M prime, and then N prime. Okay, connect my points here. All right. Okay, so again, we just glided this, translated this across the page, and now we're going to reflect this over line L. All right, so we're going to reflect it now, again, maintaining the line segment here. Again, which yours is 1.25 inches, so be sure you measure that accurately. And then we're going to we're going to reflect this over each point here, okay? Reflect this over each point. So let me quickly do this, all right? Call this L double prime. Again, making sure your auxiliary lines are perpendicular to line L, all right? Perpendicular to line L. M double prime. And N double prime. All right, and then connect your line segments again. And there you have it. So we reflected it. So a glide reflection is simply that. So it's a translation as well as a reflection. So here's number 3. Here's number 6. Okay, number 3 and number 6. Let's look now to number 7. Number 7. on page 26. Okay, so determine if each transformation below is a reflection, a translation, a rotation, or a glide reflection. Looking at number 7. All right, so number 7, we simply have one of these four. Is it a reflection, a translation, a rotation, or a glide reflection? Number 7, what would be your answer? Very good. It is a reflection. Very good, a reflection. Number 8. Now notice what happens to number 8, okay? We've seen that the object has been rotated. So therefore, number 8 would be a rotation. Very good. Number 9. Number 9. Now notice here the object again. So the object is identical. It's almost identical, correct? So therefore that would be a reflection. A reflection. Very good. So number 7 is a translation. Number 8 is a rotation. And number 9 we have is simply a translation. I'm sorry, number 8 I got wrong. Forgive me there. Number 8 looks like that is a glide reflection. All right, that is a glide reflection, number 8. Forgive me for getting that one wrong there. Number 9 is a translation. Number 9 is a translation. Simply you're just moving it across the page. Okay, forgive me for that. All right, so I want you to take a few moments, pause. I want you to take the checkup. And so for the checkup, you're going to do 1 through 4, and then you're going to do 5 through 23. You're going to do the odd numbers. You don't have to do the whole checkup, all right? So 1 through 4, and then you're going to do 5 through 23. You're going to do the odd numbers, all right? So take a few minutes, hit pause, and take your checkup. Now, all right, welcome back. We're going to do symmetry here, page 30. Symmetry, page 30. There are 2 highlights on this page that you're going to need to know. In biology, you learn about bilateral symmetry. This type of symmetry is common in God's creation. An animal possessing bilateral symmetry has the same shape on both sides of its body. Mammals, birds, and insects possess bilateral symmetry, as do many letters in the alphabet and some numbers. Manufacturers also use it to design many products. Again, you can look at the picture, the illustration on the left-hand side of your page. We see a butterfly, and a butterfly is an illustration of symmetry. The left side of its body and its right side of its body, you see, are direct, okay, perfect reflections of one another. What a biologist refers to as a bilateral symmetry is called line symmetry in geometry. Highlight this. Line symmetry can be defined as the result of a line drawn through a shape so that the figure on one side of the line coincides with the reflected image on the other side of the line. The line dividing the 2 congruent figures is called the line of symmetry. Below are some examples of line symmetry. Notice that the rectangle and square are symmetric to more than one line. So notice that triangle. All right, when we draw that line of symmetry down through the axis to the third side of that triangle, if we looked at the triangle on the left and we look at the triangle that's formed on the right, they are symmetric. If we look at the rectangle there, we draw 2 lines of symmetry. We have 4 shapes that are symmetric. And then if we look at the square, and then we draw 5 lines of symmetry, you'll notice that we have 8 shapes, that are symmetric. We use reflection to define line symmetry since it is symmetric across a line. Because rotational symmetry is symmetry around the point, we use rotation to define it. You want to highlight this second definition here. A figure has rotational symmetry when the figure rotating about a point coincides with its reflective image after the rotation. This rotation must be less than 360 degrees. Notice the propeller on the right-hand side of your page here. You'll see ABC, right? So on the right, if it is rotated first at 120 degrees, then 240 degrees, and each time that we rotate it, notice that it coincides with its pre-image, okay? It coincides. Now, obviously, if you look at the letters at each vertex, okay, so you'll see right here, you'll see A, B, C. Then if we rotate it 120 degrees, again, notice where A is located, B, and C, but still the shape coincides with the pre-image. And if we rotate it again, another 120 degrees, this would be 240, you will see, now notice the vertices, A, B, and C, but look at the shape. The shape is still symmetric to the pre-image. So we're going to quickly explain this out and practice these, see if you get this point, this concept of symmetry down. Look at number 4 on page 31. Draw the line of symmetry or lines of symmetry for these figures that have line symmetry. Okay, so, all right, let me see if I can just simply draw these. All right, draw these shapes. Let me erase my board here. All right, we have all right, now my star is a little messed up here. Here we go. All right. Okay. All right, so here's number 4, okay? So draw the lines of symmetry for those figures that have line symmetry. So here's what we're going to do, okay? So again, we're going to go notice from the points here, the vertex. Let me just simply put my book down here, okay? Through the point here, notice through here, okay? Now notice when we do that, the top half of the star is the same as the bottom half of the star, okay? So again, if I go to this point here, through here, and through here, all right, that's 2 lines of symmetry. Again, we can divide this star, okay? So if I did the top half of that star, right, it would match the bottom half of that star. So we would say that the top and that bottom half of that star would be symmetric, okay? So, all right, we could also go through each vertex there. All right, there we go. So now we have 3 lines of symmetry. All right, so then we're going to go down to this here. Okay, 4 lines of symmetry. And then we have 1 more. All right, we're going to go right through this vertex here, all the way down through that leg of that star. And then we have 5 lines of symmetry there. So, all right, so how many lines did we use? 5 lines. So draw a line, the line, or lines of symmetry for those figures that have line symmetry. Let's do, look at number 5, okay? Look at number 5 here. Now, since that's only, we're going to basically take that butterfly and we're going to draw a line right down the center of that butterfly, and then we would have, right, line symmetry. So we would say the left-hand side of that butterfly is symmetric to the right-hand side. So that could only be 1 line down through the center of that butterfly that would make that butterfly symmetric, okay? Looking at number 6. Number 6. Now, can we draw lines through there to make that thing symmetric? No. The answer is no. So we could put no lines. That does not have line symmetry. All right, look at number 7. Okay, so we have number 7. Okay, number 7 here. So if I take 1 line, and I'm going to draw right through here, is the top half and the bottom half symmetric? Yes, they are. Very good. Now, just so you don't get confused, all right, I could also draw another line. If I draw a line right down the center, are the left and right symmetric? Yes. So how many lines of symmetry do we have for number 7? Two lines of symmetry. Very good. Number 8, looking at number 8, we have a baseball diamond. A baseball diamond. So I'm going to, okay, just draw a basic diamond there. Okay, so here we have, right, left and right would be symmetric. So that's one line of symmetry. And then if I draw a line here, through there, we have a second line. So we would have 2 lines of symmetry for number 8. Number 9, looking at number 9, we have a leaf. A leaf. I'm not going to draw the leaf there, but if we can divide that leaf in half, right, drawing a line straight down through that, so we would have the left and the right of that leaf to be symmetric. So therefore, we'd have only one line of symmetry there. So very good. So understanding what is symmetric. So again, but just by way of review, again, you need to make sure these are highlighted. Line symmetry can be defined as the result of a line drawn through a shape so that the figure on the one side of the line coincides with the figure on the reflected image on the other side of the line. Be sure you know that. Now, let's look at numbers 10, 11, and 12. So write yes or no on the first line, indicating if the figure has rotational symmetry. Do the same thing on the second line, indicating if the figure has point symmetry. All right, so looking at 10, 11, and 12. Okay, so number 10, we have a propeller. We have a propeller for number 10. And so would the first blank be yes, that we do have rotational symmetry there? Correct, we would have rotational symmetry. Now, what if we rotated that 180 degrees? Would we have point symmetry? And the answer is no. Why? Okay. Now I'm going to try to draw a star the best I can. All right, that's pretty lousy. That's a pretty lousy star, okay? But if I were to turn this, again, all right, let's go back. I just want to make sure we understand the definition of point symmetry. So point symmetry is rotational symmetry of exactly 180 degrees. 180 degrees. So if I were to rotate this 180 degrees. Now remember, 360 degrees would be back to its original point, correct? If I were to rotate this 300 or 180 degrees, it would look like this. Wow, that's horrible. But anyway, you get the point. So the the star would simply be at 180 degrees, would be upside down. So we would not have rotational symmetry. So understanding rotational symmetry, if we rotated 180 degrees, it would coincide with the pre-image. So therefore, number 10 would be yes, it does have rotational symmetry, but no, it is not point symmetry. Look at number 11. Number 11. So again, if we rotated that 180 degrees, or excuse me, 120 degrees, it would be rotational symmetry. So it would keep, the shape would coincide. But again, if we turn that, all that is simply, right, we see number 10, there's a propeller, number 11, okay, it's simply a star. So if I rotate that 180 degrees, would we have point symmetry there? No, we would not. Again, very good. So yes for rotational symmetry and no for point symmetry. Number 12, that's pretty simple, right? It's simply a circle. So if I rotated that 120 degrees, if I rotated that 180 degrees, we would still have a circle, right? So the circle on the top would coincide with the circle on the bottom. So therefore, blank 1 and blank 2 would simply both be yes, all right? Yes. Now, looking at number 13, 14, and 15. Write the letters of the alphabet that have vertical a vertical symmetry line. Write the letters of the alphabet that have a vertical symmetry line. So let's just take, all right, let's write here A, B, okay. So what we're going to do is draw one line, okay, a vertical line. So if once I draw a line, if the left side coincides with the right side, then we would say, okay, it has vertical symmetry. So what letters of the alphabet have vertical symmetry? So let's begin with the letter A, all right? Let's look at the letter A. If I simply put a vertical line down there, will we say that the left side coincides with the right side? All right, so A, very good. A would have vertical symmetry. How about B? No, very good. How about C? No. D? No. E? No. F? No. G? No. But how about H? If I drew a line, vertical line down through the center of H, does the object on the image on the left-hand side coincide with the image on the right-hand side? The answer is yes. Very good. All right. How about I? If I draw a vertical line down through I, we would have vertical symmetry. Very good. Not J, not K, not L, but how about M? So M would have vertical symmetry. Very good. How about O? Very good. O would have vertical symmetry. P wouldn't. How about Q? No. R? No. S? No. How about T? Does the object on the left coincide with the object on the right? Therefore, we have vertical symmetry. Very good. How about U? Right down through the center of U. Yes. How about V? Yes. How about W? So W, yes, very good. How about X? Great. And then Y. So they are the letters that have vertical symmetry. Write the letters of the alphabet that have horizontal symmetry line. That have a horizontal symmetry line. So, okay, now, obviously, A would not, but how about the letter B? Does the object above coincide with the object below? The answer is correct. How about C? How about D? Good. You get the idea there? How about the letter E? The object above, right? The image above coincides with the image below. Very good. G would not. How about H? H would. Very good. I would. Not J, not K, not L, not N, not N. How about O? I think I missed one. I did miss K, because if I look at K, the object, the image above does coincide with the image below. Very good. We have O. Okay, O does. And there's one more. And that would be the letter Z. The letter Z. If we divide the letter Z there, we see that we have horizontal symmetry. Now I want you to do number 16 and 17 on your own there. Number 16 and 17, which is the numbers, which numbers have vertical symmetry line and what numbers have a horizontal symmetry line. All right, we're going to get to page 33, 34. We're going to end that in just a few moments. And so what we're going to do here, and so beside using the common methods of proving triangles congruent, which we've done this whole course, right? Angle, side, 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 angle, side, all those postulates. Remember, we use those to prove triangles congruent. We also can use isometries to prove congruence. And so if one triangle can be mapped by an isometry onto another triangle, then the triangles are congruent. And we could use that by simply doing isometry. So we're going to quickly do page 34 together, all right? So I'm going to do, we could do 2 and 3 together in class. You will do number 4 on your own, okay? So proving triangles congruent by using an isometry. So let me see if I can draw my triangles here. All right, we have triangle A, B, C. And then we have, I'm going to draw closer here. I'm trying to get my shape nailed down here. So let me go a little bit like this. Okay, I think I got it. All right, this is as close as I'll ever get it. All right, we have A triple prime, B triple prime, and C triple prime. Now, all right, so I really want you to follow quickly the steps with me. Again, forgive me for not having the proper tools with me, but we're going to try the best here we can. So what we're going to do is we're going to draw auxiliary lines. And so what we're going to do is just follow the alphabetical order. So we're going to go A, then B, then C. And so what we're going to do is A, we're going to connect A to A triple prime. So get your straight edge and draw a line from A to A triple prime. All right, so obviously, again, my ruler's not long enough. Figures here. All right, going to connect that. Okay. So we're going to go, now what we're going to do is we're going to take this triangle here, A, B, C, and we're going to map it right on top of A triple prime, B triple prime, and C triple prime. So we got to move this triangle. So that's how we're going to do this. So now, once we draw that auxiliary line, okay, everyone do that? So from A to A triple prime. Now what I want to do is I want to find the perpendicular bisector of that line. Find the perpendicular bisector of that line. Do you remember how to find a perpendicular bisector? We stick the compass point of our compass on the end of the line segment. We open up the compass a little more than halfway. All right, so that's what I'm going to do here. And I am probably not going to be able to do this again properly because I can't go above. I did my triangle too high. We'll try it. I'll even write on top of the board here. There we go. Look at this. Okay. All right. Now, once we do that, all right, so right through our intersections, we're going to draw our perpendicular line, okay? Now, all we're going to do, once we do that, okay, we're going to reflect points B and point C over that line. We're going to reflect point B and point C. So, okay, let's do this here. So we're going to go, all right, so from B, all right, so from B to my perpendicular line, all right, you're going to do your measurement. So I don't know what your measurement will be. Let's see. I think I could do this here. I think it's, I'm going to do inches here. So it's going to be 2 inches, 2 and... If you're counting the little lines inside your, in between the inches there, they're 16ths. So I'm going to go 2 and 14/16, okay? So 2 and 14 little 16ths there. All right, so now I'm going to go, I got to do mine. So, all right, so. Okay, all right, now we're going to call this B double prime. All right, so we reflected B across that line. Now we're going to reflect C across that line. Be sure, again, we're preserving that isometry. So I have here, and again, make sure that line is perpendicular. So 2 inches here. So... all right, we're going to call that C double prime. All right, now notice, okay? Look at the board here. Okay, look at, I have A triple prime, and I have B double prime and C double prime. Notice the triangle I have. Let's connect those points. So A to C. All right, A to B, and B to C there. Did you see the triangle that we made? Now I'm going to use a different color marker. I'm going to go back to black here. Now we're going to take, so we just, remember, our first line that we drew A to A triple prime. So then we found the perpendicular bisector. Now I'm going to go from B, all right, the point that we just drew here, B double prime, I'm going to connect it to B triple prime. Okay, B double prime to B triple prime, or B prime, so it should be B prime, but I'm going to connect them two together. I'm going to use a black marker here so you can see. All right, so I connected B. All right, trying to find the best marker that works here. Let's try green. All right, green works. Okay. Once I do that, now we're going to repeat the process over and over again. So we're going to repeat it. So once I did, remember, we started off, we do auxiliary line from A to A triple prime. We found the perpendicular bisector. Then I reflected the other two vertices. Now we're going to connect B prime to B triple prime, and then I'm going to find the perpendicular bisector of that line. Okay, so again, stick your point on the end point there, open a little more than halfway. There. All right. Found the perpendicular bisector. Okay, connect that point. All right. Now this becomes my line of reflection. Notice we've already reflected B prime, right, to B triple prime. Now I want to reflect the other 2 points here. Okay? So if this is my line of reflection, we're going to reflect those other 2 points here. So what are those other 2 points? Let me extend this, extend that there, okay? All right, so here's my line of reflection. Here's C. See C here? Okay? We're going to reflect simply C over here, and then we're going to reflect A. Okay? Just trying to be neat here, as neat as I possibly can. All right, so let's see, did I do that right? I connected B to B prime. All right, you can get lost in here. That's why I don't want you to get lost. All right, so now what we're going to do here is reflect C. So here's point C. You can see it here. We're just going to simply reflect it on this side. Call that C double prime. All right, and then we have, okay, so B has already been reflected, and now here we have A. So we're going to simply reflect A. So once we reflect A, so now we have A, right about here. So connect these points here. Starting to get messy. Starting to get messy. All right, so what I'm going to do is, I don't have the proper tools, so forgive me here. So I'm going to try to, how much time we have, Mom?
We have 39 minutes.
All right. I'm going to start this over again, all right? Just so, because I'm going to have to, I just got to make mine a little bit bigger so you can see, all right? So forgive me. I'm not going to try to be so accurate. I'm just going to walk you through the technique, and then you could do this on your own here. So forgive me for this. Okay, all right. I'm not going to use any tools because I don't have the proper tools. So I'm just going to show you how to do it. All right, so A, draw your auxiliary line, okay, from A to A prime. You should have already done that. Okay, get our perpendicular bisector. So get our perpendicular bisector as such. Then just we're going to simply reflect these points over, okay? Reflect these points over, maintaining your proper distance. So we're just going to go just here. We're going to call this B prime, all right? And then C here, we call this C prime. Okay, all right, we have our triangle here. Okay, there we go. Now from here, we're going to connect B to B again. We're going to find that perpendicular bisector. Once we find that perpendicular bisector from B to B, B triple prime, now what we're going to do is simply reflect our shape again. So since we've already reflected B, now we're going to reflect C. Okay, so from this point here, here's C prime there. Everyone see, you make sure you see that there. All right, so from there we're going to go to here. Okay, so from here to here. We've already reflected these two. A is already on the line of reflection. And so if I connect these, look, so as I connect A to C, we're right on top of the shape. Did you see that? We're right on top of the shape. So we mapped this triangle once and then mapped it again and literally mapped it right on top of the original triangle. So therefore we know that the triangles are congruent. The triangles are congruent. Let's do one more. I want to do one more and try to, again, forgive me for not having the proper tools to do this. So we have triangle A, B, C, right? A, B, C. And then we have so we're going to call this A triple prime, B triple prime, and C triple prime. Okay, so A to A triple prime, draw your auxiliary line. Then we're going to find the perpendicular bisector of that line. Again, you make sure you use your proper tools. Get your compass point, stick them on the end point, open it a little bit more than halfway, draw your arc above and below. Keep the opening the same, stick it on the other point, do the same thing, and you should get your perpendicular bisector. Once we do that, we're going to reflect now each point. So we're going to reflect C over, okay, go to C prime, and then we're going to reflect B over as well. So reflect point B, okay, that's all right, we call this B prime. All right, so now if I connect my points A to C, C to B. All right, now let's connect B to B prime, B triple prime. Connect those 2 points together. All right, find the perpendicular bisector of that. Find the perpendicular bisector. All right, so we do that and try the best I can. All right, there's your perpendicular bisector. From here, okay, this is the shape that we're talking about here. B is already reflected. Now I got to see A is already on the line of reflection. So now let's just make sure C is perpendicular, and we want to connect that. We're going to call that C double prime. All right. So connect these together. So A to C, C to B, B to A. Now we're going to take this triangle. Here's the original one. Let me draw the original one in blue so we understand what we're doing here. I'm going to take this triangle, and now we're going to do it one more time. So we did from A, remember, A to A prime, found the perpendicular bisector, reflected. Once we did that, we went from B prime to B triple prime, found the perpendicular bisector, then reflected the other two vertices. Now we're going to go from C double prime to C triple prime, connect them with an auxiliary line. Okay? Let's find the perpendicular bisector. So we find the perpendicular bisector the best I can here. Let me see if I can, looking at my book here. Alright, let's see. Alright. Okay, now watch. C is already reflected. Okay. A is already on there. B. Now if I connect these, look, again, we are right on the original triangle. So mapping. So we'll pick this up again tomorrow. I want you to do number 3 or number 4 for homework. I want you to do number 4 for homework. So 2 things I want you turned in. I want the checkup in by 3 o'clock, and then page number 34 will be due tomorrow. All right, have a blessed day, and be safe.